for that volume. So the outer radius is from your axis of rotation to the outside edge of the curve, which in this case would be 6. So we're going to do part A, pi times. Oh, and we're going from, we got to figure out where they intersect. Figure out our bounds. We need to know where these two graphs intersect. Yeah, this is number 2. 1 and 2 you can use the calculator on. 3, 4, 5, and 6. So we'll clear out our last box. And we'll put this in. So x to the 4th minus 2.3x squared. Oops. Plus 4. And then y equals 2. No, I did something wrong. Oh, not y equals 2, y equals 4. Alright, so we want to see where they intersect, because that's going to be the bound for our solid here. So I'm going to do menu, analyze graph, intersection. I think they intersect starting at 0, but I'm just going to make sure by figuring it out. Yeah, 0 is the first one. Menu, analyze graph, intersection. 1.51658. So since that's not a whole number, I'm going to store it because I'm going to have to use it in a minute. So once you figure out those 2 points of intersection for your 2 graphs, go ahead and store that second one. So remember, hover over it till it kind of turns light gray, and then control menu. I'm not going to store the 0 because that's a whole number. I mean, you could, but I can type a 0 in just as easy as I can type letter in. But this one, I don't want to round it. Since it's not a whole number, I don't want to round it because then I might get a compounded rounding error. So I'll save this one as, we'll do B. Oh, it doesn't matter, I'm going to call it B. So I'm going to make a note on my test that I am calling P 1.517. So that they know every time they see P that that's what I mean. Alright, so we're going to go from 0 to B. Of the outer radius squared, which we just said, the outer radius is 6. So the outer radius squared minus, and then it's inner radius squared. So now we got to figure out what the inner radius is. Now the inner radius is not a constant. So we have to figure out what the inner radius would be.
Yeah, that's what I'm thinking.
Really? Where they intersect?
Yeah.
So all got 2.3? Okay, then. Oh, it's x cubed, not x squared. Let's try this again. I hope that makes y'all feel better. There we go. Okay, let me try this again. Menu, analyze graph, intersection. Yeah. Then change window settings. Go to menu and window. Oh, okay, so it is just 2.3. It's not a whole big decimal. When we don't have to do this, we can just write 2.3. That makes it a little bit easier. So you can still store it as P if you want to, but I'm just going to do 2.3 since it's a number I can actually, I don't have to round it to use it. It's just 0.3. Okay, so the inner radius squared. So notice the inner radius is not constant, right? The inner radius is from the axis of rotation to the inner edge of your area that you're rotating. And it's not a constant. So any guesses on what this would be? Yep, so the distance from -2 to that, so what would that be? To this curve right here. Yeah, it's kind of tricky. So the distance from the x-axis to that curve is just the y values on that curve, right? From the x-axis to these points. So this would be the distance from the x-axis to the curve. F of x is that distance, right? F of x is y, and the y is the distance from the x-axis to the curve. So it's just f of x plus 2, right? Since our axis of rotation is 2 below the x-axis, it adds 2 onto all of those, right? So it would just be f of x plus 2 would be the inner radius. Because remember, we do radius squared, right? Because you're doing area of a circle, which is pi r squared. We just happen to have 2 radius. Yes. Yeah. Yep. So this is outer radius. So we're just a constant 6. This is inner radius. Now, what if the axis of rotation had been at +2 instead of, or at +1, or +0.5 or something, I don't know. If it had been above the x-axis instead of below. The outer radius would have been different, it would have been smaller, right? Instead of +2, if the radius was above the x-axis, you would have had to subtract, yeah, whatever the distance was. But when it's below the x-axis, it adds to the radius, right? Because you're getting further away from the graph. Okay, so we would just type in our calculator. And like I said, we're going to do several of these, so I think you'll feel a lot better about it. It's actually, to me, one of the, free response questions you can actually feel good about, because it's pretty much guaranteed to be on there. They only ask, certain few questions, and if you can set it up, it's a calculator. It's just the setup that's hard. Once you get it set up, you just type in the calculator. So pi, and then menu 42, from 0 to 2.3, of 6 squared minus f1 of x plus 2 squared dx. So make sure you're careful when you type it in. You want to make sure that the f1 of plus 2 gets put in parentheses and a square goes outside, right? You don't want to just square the 2. You want the whole thing, f1 of x plus 2, to be squared. You got it in parentheses. 98.868. So this was the 2014. Look and see. Number 2. Alright, this first part is worth 4 points. Alright, so 2 points for the integrand, which means knowing that it was 6. And they put 4 plus 2, but it's fine to put 6. You don't have to put 4 plus 2. 4 plus 2 squared minus f of x plus 2 squared. 1 point for knowing that it was from 0 to 2.3, and 1 point for the answer. So 4 points for that one. And the scoring statistic for this one, number 2, the average number of points somebody got this year was 3.39. So most people didn't even get all 4 points on the first part, much less any of the other ones. So it's a little over 3 points with the average. In fact, none of the questions in 2014 had an average score above that was 4 or higher. All of the questions were 2 or 3 points. All right. You going down to biology? I'm recording it, so you can catch up. Okay. All right. So to me, that was the hardest part of this one. So it's nice that it was worth the 4 points, because I think it is the hardest part of this question. Okay. So then on part B, it says region R is the base of a solid. Now that I've completely marked this out, you're not able to see anything. Region R is the base of a solid. For this solid, each cross section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. So this is that solids with known cross section one. So instead of rotating the area to create the solid, they're going to take this area. I'm going to try to draw it here. Something like this. And they're going to draw isosceles right triangles, which means triangles where both of the sides are the same length. Yeah. So it creates like this weird 3-dimensional shape, which is really not important, like I said, for you to understand like exactly what the shape's going to look like. You just need to know that to find the volume of that kind of a shape, you integrate the area of the cross section. So the key is just to figure out what would be the area of the cross section, because that's what I'm going to integrate. Right. So on part B, cross section is the shape, like this kind of like these. Instead of rotating to make this shape, you have the triangles rising up out of the paper, and each triangle has a base and a height that are equal to the distance between those two. Like that's what creates the shape. It's that distance right there. Okay. So you have all these triangles making up this shape. Yeah, it's crazy. And it's really hard to try to draw it. So something kind of like that. But the thing is you just need to know that each cross section is a triangle with 2 sides that are the same. We just got to figure out what those sides are. Right. Yeah, and so it would be the sides are in here in R. Right. Cross sections that are perpendicular to the x-axis, so they go this way. Right. So we're gonna integrate from 0 to 2.3 the area of each isosceles triangle. And by isosceles means two sides are the same. So basically we're gonna have 1/2 the base times the height. But since the base and the height are the same, I'm just gonna say 1/2 the base squared. Alright. Area of a triangle is 1/2 base times height. And in an isosceles right triangle, the base and the height are the same. So we're just gonna say 1/2 base squared. So what is one of those bases? What is this distance here that makes the side of the triangle? 4 minus f of x, right? It's the distance between these two curves. So all the way to the line is 4. From the x-axis up to the curve is 4. And then to the bottom curve is f of x. So we're looking for the difference between those. So it's 4 minus f of x. Top curve minus bottom curve. 4 minus f of x. So we're going to type it to our calculator. 0, 2.3. 1/2. And you could put the 1/2 inside or in front. Just like on the first one, I put the pi outside. You could put it inside. Doesn't really matter. Normally I'll put constants on the outside. I just didn't do it on this one. But 1/2 4 minus f1 of x squared dx. Let's see. Make sure that the 4 minus f1 of x in parentheses. 3.574. And this is worth 3 points. Yeah. I'm actually kind of surprised on this year that they didn't ask for the area between the curves, because normally part A is area, part B is something volume, and then part C will be something kind of random. So part B was worth 3 points, 2 points for setting your setup, showing that you did 0 to 2.3 of 1/2 4 minus f of x squared, and then 1 point for your answer. Alright, so what did I do? Who said that?
John.
Mitchell? Oh.
No.
Okay. It's cold. Alright, so part except when you get in my room. Yeah. Well, the fluffier you are, the more cold you need it in your room. So we're fluffy. Actually, even when I wasn't fluffy, I think I get it from my dad. He would sleep like with the windows open in the winter if he could. And then my stepmother is the opposite. My stepmother's like, she'll wear a sweater when it's like 90 degrees outside. They fight over the air conditioner all the time because my dad can't stand to be hot when he's asleep. So before he goes to bed, he'll turn the air conditioner down. What's up, Cameron? By your lack of papers, I'm assuming you don't have your package.
Oh, I got them. I actually, wait. I'm on my car. I'm not.
Give me a second and I'll print you some of what we're doing today. I don't think I have any more, but let me finish this problem and I'll. Oh wait, maybe. Oh look, you're lucky. I have a response right here. I'll have to print you some multiple choice if we do any of those though. Response. Okay, part C. This is a random one where they asked us a different. Last time they asked us to do like a derivative. This one, part C, says the vertical line x equals k divides R into two regions with equal areas. Write but do not solve an equation involving integral expressions whose solution gives the value of k. Yeah, you don't have to solve it. All I do is set it up. And before I tell you what it is, let me make sure that I'm not oversimplifying. Huh? Yeah, help yourself. You can't have any kids relate, and you didn't come prepared. Just kidding. Okay, yeah, so this part is actually super easy, but because it's so easy, like, you're going to doubt yourself just like I just did. I had to look and go, okay, is it really this easy before I told them how to do this? Okay, so they're going to divide R using a vertical line so that these two areas are equal. I've like totally destroyed this drawing. So they want you to be able to figure out what the value of k is. So in order for these two areas to be equal. So the area for this first half would go from 0 to k, and it would be we would integrate top curve minus